This is Wells Math. Today I want to talk about equivalent fractions and exactly what that means. When I'm teaching this skill to my students, I always like to give them a visual, something to look at to help explain what equivalent fractions really are. First of all, the word equivalent is just a fancy, bigger word that means equal. Okay, so let's look at our rectangle we have. Obviously, we can see that 1/2 of that rectangle is shaded in orange. Let's pretend that this is a candy bar and you ate half of the candy bar, one out of the two pieces. Then let's watch this. I'm going to split up this candy bar into now 4 equal pieces. Well, you noticed I did not do any extra shading. I did not shade any more of the total rectangle in orange. Now we do have 4 total pieces. That's going to be my denominator, my bottom number in my fraction. But now we have 2 pieces that are shaded. So if there's 4 pieces of candy and you eat 2 out of the 4 pieces, that's the same as eating 1/2. Let me do this one more time. Let's pretend that this candy bar has 8 total pieces. And out of those 8 total pieces, we have 4 that are shaded orange, or those are how many that we're going to eat. Well, if you eat 4 out of the 8 pieces, that's the same exact thing as eating 1/2. Okay? So that just gives the students a quick visual. Let's look at the next one. Let's look at the circle. All right. Obviously, there are 3 total pieces in the circle. That will be our denominator. And 1 out of those 3 pieces are shaded green. Okay. Let's pretend this is a pizza. Okay. There's like a personal pan or something, and there's 3 total slices, and you get 1. But what would happen if the slices were smaller and we took each one of those pieces and split it? Now, how many pieces are in the entire pizza? Well, you can just count those total amount of pieces, and there are 6. Now, you notice I did not shade anymore and in green, and now there are 2 pieces. 1/3 is equivalent. It is equal to 2/6. Okay, so that just gives students a visual representation of actually what equivalent fractions really are. But there is a little shortcut. I mean, your teachers probably don't expect you to draw these pictures every time you're trying to come up with an equivalent fraction, right? So here's one step, one easy way that you can turn any fraction into an equivalent fraction. So let's look at a lesser known fraction that we don't use a whole lot. Maybe like, how about 3/7? Okay, and let's pretend your teacher just says, "Hey, give me a couple of fractions that are equivalent to 3/7." Well, look what I have up here. It just says multiply the numerator, the top number in the fraction, and the denominator by the same number. Okay, so I'm just going to pick any number in the world. Let's just do something easy. Let's do times 5. That's an easy number to multiply. But you have to multiply the top and the bottom both by 5. Well, when you do that, when you get 3 times 5 equals 15. 7 times 5 equals 35. So 3/7 is equivalent to 15/35 or 15/35. And you could do this with any number. We could make that 5 into a 6 right here. We can multiply the top and the bottom by 6. 3 times 6 would be 18. And 7 times 6 would be 42. So if your teacher asks you, hey, give me a couple equivalent fractions for 3/7, hey, first we multiplied the numerator and the denominator by a 5, and then we multiplied the numerator and denominator by a 6. That gave us 2 equivalent fractions. Okay, so as long as you multiply the top and the bottom by the same number, that is crucial. It must be the same number. You will automatically get an equivalent fraction. Let's look at the next one, though, what it says. It says divide the numerator and denominator by the same number, if possible. Okay, so with the first one, you can always multiply the top number and the bottom number to find an equivalent fraction. You may not always be, no, you won't always be able to divide both. Let me give you a quick example. How about let's just do kind of one a little basic. We had the fraction 5/15, and we wanted to see if we could divide this fraction by the same number on top and bottom to get an equivalent fraction. Well, what you would want to think here is there a number that will divide evenly into 5 and to 15? Well, if you know your multiplication facts, you know that 5 will go into 5 one time, and 15 divided by 5 will go into 15 3 times. Change the color there. 15 divided by 5 is 3. 5 divided by 5 is 1. So if you had 15 pieces of candy and you ate 5 of those pieces, 5 out of the 15, that's the same as eating 1/3 of the candy. Okay, this is also called simplifying. I have a video on that if you want to check that out. Simplifying fractions, also putting fractions in simplest form. Go check out that video if you need a little bit more clarification on that. But like I said, it says divide the numerator and denominator by the same number if possible. You may not always be able to do it. Watch this one. How about 2/9? Well, I'm thinking about a number, or if there is a number that will divide evenly into 2 and into 9, but it has to be the same number. Cannot be different numbers. Okay, let's make that very clear. There is not a number that will divide evenly into the number 2 and into the number 9. I had a kid once say, well, Mr. Wells, what about the number 1? Well, yes, the number 1 will divide into both. But if you do that, 2 divided by 1 is 2, and 9 divided by 1 is 9. You end up with the exact same fraction. So you may not always be able to divide your fraction to get an equivalent fraction. Okay. I hope this helped out. Check out my YouTube channel at Wells Math. I've got a lot more videos that you can check out, even more on simplest form and simplifying fractions. Go check those out. Hope you have a great day.